So it's my great pleasure to kick off this meeting with a talk on what's new in CCP-EM and our software suite. This was checked and I was assured that I wouldn't get any blinking. So so I'm going to give you what's new in CCP-EM, but I'm also but first, I'm going to indulge myself by doing a little bit of history. So I want to take you back to the heady days of 2012. In the outside world, lots of exciting things were happening. So London was hosting the Olympics. A couple of other events here. I'm not going to tell you what these are. I'm going to leave that as something for you to ponder. I realized that in 2012, many of you were probably still going to school, or maybe you were crystallographers. But things have moved on since then. EMDB was up and running in 2012. People were depositing structures, so there were about 400 being deposited in EMDB, and that number was slowly growing. But this was before the resolution revolution. So the highest resolution in 2012 was 3.5 angstroms. And then in that same year, we got our first funding to set up CCP-EM. This was inspired by the success of CCP4 for crystallography and CCP-N for NMR. And a few of us pushed, largely by Helen and Richard, said that we should do the same thing for EM. And in February of the following year, a few of us gathered in Leeds to try and work out what we could do. Moving forwards a little bit, in 2015, there were a number of firsts. So we had the first Spring Symposium, as Patient mentioned. Yeah, that's the agenda. Probably too small for you to read, but you can have a look at it later. But you should recognize a few names on there. We made an alpha release of our first software suite, which had a relatively small collection of programs, but with a GUI and some admin tools. And over in EBIC, well, the building hadn't been built yet, but they had CryoSwan set up in the ring. And that collected its first data sets in November of that year. Skipping forwards again, in 2018, we made our first release of CCP-EM version 1. This had a more comprehensive set of tools for map manipulation and model building. Lots of it based on CCP4 tools. Relion was included, but as a separate application. And it came with a GUI and various project management tools. So where does that leave us now? We serve quite a large community now. So we have over 3,500 subscribers on our mailing list. We're getting lots of downloads of the software suite, and a number of pharmaceutical companies also license the suite to use in-house. And we have a network of developers, so we collaborate with over 10 development groups around the world. We're very grateful to have had funding from MRC for continuously since 2012. And as Patient said, you've been holding a Spring Symposium every year, and this is now up to 366 here and 756 online. We've organized or co-organized a large number of workshops, and we've also contributed to other people's workshops or conferences. Just to have a shout out for COSEC, which is an organization which brings together a lot of CCPs or collaborative computational projects. So CCP-EM is one of a family of CCPs in various scientific areas. So CCP4 for crystallography, you probably know. The CCP-N for NMR, the CCP Biosim for biomolecular simulation, and then various other ones in areas of material science or engineering. And COSEC is due to grow, so there'll be more CCPs along the lines of CCP-EM. So that's our progress to date, a little bit of history. A couple of years ago, we sat back and thought, you know, what did we want to do going forwards? And we decided it was time to kind of redesign the software suite from the ground up, in particular taking advantage of web technologies that are coming along. So this is, you know, roundly speaking, our vision is to be able to go from collected images through to deposition in the international archives, and have a toolkit and a software suite that would automate all of this and guide the user through it. So our next generation of software is based on this kind of hierarchy. Doppio is the name of the graphical user interface that most people would interact with. Underneath that, there is a pipeliner layer, which is the business end of the suite. That's the thing that runs jobs, coordinates workflows, handles metadata. And beneath that, there are specific lists of tasks. So things that you might do in Rely On, or things that you might do for model building, or anything else. And these tasks are plugins that will go into the pipeliner system. So going into that in a bit more detail, pipeliner is the business end. This is a separate open source package. We've made it open source in the hope that other people will make use of it for designing their own workflows. It tracks metadata, and part of that allows it to build up these workflows. So, you can have a project that exists as a graph of jobs or a workflow, so you can navigate yourself around a project. Particular apps come in as plugins, and these are, for developers at least, these are relatively easy to write. So we're encouraging third parties to contribute to the infrastructure. Every particular job type has input and output nodes defined. So Refine 3D from Rely On will take information about the particles and the reference model and output refined maps, half maps, etc., etc. This is actually modeled very closely on what Rely On does anyway. So if you look in Rely On in a pipeliner.star file, you will see similar type definitions. What we've done is to extend this to the whole of the CCP-EM suite. So model building jobs in particular will also have input and output nodes defined. And this gives us the basis for connecting single particle reconstruction to later stages of map interpretation and model building and deposition. So yeah, pipeliner is meant to be a very kind of flexible architecture and allow you to design your own workflows. So this is just an example of a workflow that Matt did in-house. Is to look at how reconstructions vary as you change the number of input particles going into it. So there's a little workflow set up here. Separate the particles into half sets, and then you can shrink these half sets and look at what the effect is on the reconstruction. So that's just an example of doing a novel workflow using the pipeliner tools. And this is probably aimed at developers mainly. This can be done through a bash script, calling pipeliner itself. So you start a project, you set up the input parameters, you run it, etc. You can link together different jobs. And there's also a Python API, so you can do the same thing in Python. Where it has been used in anger is at EBIC for the automated processing of single particle experiments. So when you collect an ePick, it sets off an automated data processing that goes through particle picking and as far as it can go. And that workflow is based on Pipeliner underneath. Yeah, so when that workflow runs, the output is put into iSpy-B, so you can actually then download the processing project from iSpy-B, and it will launch into CCP-EM, into Doppio. So it's completely compatible with what we're doing. So an important part of Pipeliner is tracking the metadata. It links to the jobs together through input and output nodes. Every job records the metadata that it's used. So metadata is things like job parameters, how you ran it, whether it was successful or not. And the upshot of this is that you can kind of select any job in your CCP-EM project and track back to see where those results came from. So, you know, what were the particle sets that you used to get your final maps that you're depositing into EMDB. So yeah, within Doppio, there are a few tools. You can select any particular job and get a summary of the metadata that led to that job. You can also get a list of literature references. So this is to encourage you to cite the 4 people that are writing the software. And then given all of this metadata and all of this job management, you can then simply archive your project for later use. So there are tools in there. You can either download a script that allows you to rerun it, or you can download the whole project, including all of the files. And if you're archiving for yourself, that leads to the obvious thing that you can then contribute this to public international archives. And for Empire already has an Empire depositor script that allows you to collate the data that you would want for an Empire deposition and upload it to Empire. What we've done is to create a tool that will collect all of the information from you using the information that we're holding in Pipeliner. So you can generate, using this particular task interface, you can generate a single file containing all of the project information and then upload it to Empire. So you do need to have an Empire ID in order to do the actual upload, and it's probably advisable to talk to Empire staff anyway. We're working on doing a similar thing for EMDB and PDB to connect information collected in Pipeliner to the OneDep system. So that's work in progress. And I think Kyle will say a little bit more about OneDep in his talk. So Doppio is the graphical user interface, which sits on top of Pipeliner. There are interfaces for all of the different job types, for rely-on jobs, or for map sharpening jobs, or for model fitting jobs. These interfaces are defined within Pipeliner itself. So Pipeliner defines what information should go into the interface, and then the interface is auto-generated. We do have this concept of themes, which allows you to customize which jobs are included in the interface and how they're presented. And we've defined some default themes for you. So for instance, there is a single particle analysis theme that will just give you the reconstruction jobs, the rely-on jobs and associated jobs without the clutter of other things. And there's a model building theme as well, but you can also customize this yourself. So yeah, Doppio is built with JavaScript. It's built using kind of web technologies. So this, we have in mind that we can then deploy this in different ways. So the simplest way to deploy it is on your desktop, so that it runs like Rely does, or like earlier version of the CCP-EM suite does. But you can also split it up. so that the business end pipeliner and the underlying applications is running on some server somewhere, and the GUI is on your local system, and it will communicate over the web. So you set up jobs locally, and then you send the instructions to the server to run it. And this can also be set up on cloud services. So this is actually how we now run our training courses. We have everything set up on our cloud service back home at STFC. And then on the training course itself, we just have the Doppio client where the students can set up jobs and then have them running on our cloud service. So I think this remote operation will be very powerful. It's not yet fully supported. It probably needs a little bit of help to get set up. I mean, it does work. We use it in the training workshops, but there may be a little bit of setting up to do. There are some limitations. The main limitation at the moment is that if you launch third-party apps, such as launching Coot, that won't work under this system. So just to give a quick run through some of the capabilities of Doppio. So first of all, setting up new jobs. So I have a video I hope I can talk to. So you can select a menu of new jobs, go through the list and find the job that you want to do. If you can't find it, there's a search bar, which will cut down the search. So when you've selected the job that you're interested, you click on it and a panel opens up on the right to allow you to input the necessary information. There's a job info button which will tell you what the task does, and with some links to documentation. You can set a job alias very much along the lines of how Relion does that, and then select the input files. You can select these from output files of jobs that you've run previously, or you can upload directly from disk. So this is an example of multi-reference refinements. So you can input multiple reference files with a plus button. There are default parameters for most jobs, but you can change these. There's some sanity checking, so that just went past, but it'll tell you if you put in an incorrect point group, for example. Click run, and then it sets the jobs going and opens up the log output, so you can see the output of the programs as they're running. So this then brings up the results pane, which has 4 tabs here, which I'm going to now talk about in a little bit more detail. Results essentially gives you the most important results that are coming out of a particular job, summary and highlights. Logs, again, gives you all of the output from the programs. You can see all of the gory detail if you need to, if something has gone wrong. IO tab tells you about the input and output files and links to third-party applications. And options just gives you the parameters that you selected when you ran it. So I've said all that. So if you go to the next video, so you can look at the results of any job that you've previously run. So you can scroll down, look at a particular job. There's a drop-down menu which gives you different ways in which you can interact with it. So you can open up this job in the workflow and see where it sits with respect to other jobs. You can clone a job. So it means you can rerun the job with maybe a different data set or different parameter choices. But if you just simply look on any of these jobs, you get the results panes, and this gives you the highlights of the jobs. So it'll be things like, 2D class averages, 3D class averages, output reconstructions. We have a Molstar viewer embedded, so you can look at 3D information interactively. Log files gives you all of the details, as I said before. And then the IO tab is one of the most useful ones. It lists the input and output files, and it has helper applications connected. So if there's a star file, you can open it up in a text viewer. If you have a map file, then you can open it up in Qt or Chimera. So these will launch as their full applications on your desktop. If you want to look at things very quickly, then you use the Molstar viewer, and that gives you a quick view of the output. So for mask creation, you can check that the mask is sensible around your reconstruction. This is an example of fetching something from the PDB, so you can have a quick look to make sure that you downloaded what you thought you were downloading. And if you then refine that in RefMax ServalCat atomic model refinement, it will give you a quick view of how the model is fitting into the map. And if you want more detail, of course, then you would launch this into Qt using the IO tab to do more sophisticated editing. So that's just a quick montage of some of the things that are in the latest version of Doppio. So we have task interfaces for kind of everything that's in the core CCP-EM suite, and for a few third-party apps as well, third-party programs. In many cases, those third-party applications may not be available, and in this case, the task is grayed out. So in this example, I haven't installed Modelangelo properly on my system, and so that's not available. So the latest Doppio is compatible with Relion 4 or Relion 5. So Shores is going to talk later about Relion 5. So in the context of Doppio, we have interfaces to everything that you can do in Relion, very similar to the Relion's own interface. The difference is that that's integrated into the wider ecosystem of CCP-EM software. And also you have access to a lot more of these visualization tools. So if you run anything in Relion, you can have a quick look at the particle sets or the class averages or whatever. Another thing that's going to be talked about later today by Thomas, Tempi-Ref is the latest from the Hamburg group on Tempi. So this gives you ensemble refinement of models into maps. Thomas will talk about that later. Hot off the press, Moorhen is the web-enabled version of Qt, and we've just integrated this into Doppio. So on the IO tab, besides Qt and Chimera and UglyMol and other things, you can now also launch this into Moorhen, and that will open up not as a separate application, but embedded within Doppio. And then you have access to the full range of visualization and editing tools that are now in Moorhen. So Philo is going to talk about this in far more detail later. It's just to show that you can do editing. So that's an example of removing hydrogen atoms if you don't want them. There are tools for validation and for ligand building. And if you make any edits, then you can then save these edits, and that would become a new job in Doppio. So in terms of the Doppio workflow, you'll have a Moorhen job there that describes how you've changed a model so that the workflow is not broken. A couple of other highlights. I mean, so validation is very important in cryo-EM, as I hope you're aware. I hope other speakers will say as well. So we have a variety of tools for validation within the suite. So just to highlight a couple. So we have Find My Sequence and Check My Sequence from Greg in Hamburg. And this will basically validate the sequence that you've built into a very low resolution map, tell you if you have a register error or something like that. And if you don't have a sequence, it will even go and look for one up one for you. In collaboration with EBI, we've also got a copy of the EMDB validation analysis. So for a deposited structure, this is what you would see on the validation tab in EMDB. This is recreated within Doppio, which means you can do your own validation before you have the embarrassment of submitting it to EMDB and getting it back. So it comes with a lot of graphs and snapshots, which hopefully are reasonably familiar from the EMDB pages. So that's a kind of quick tour of what we've got in Doppio 1, and I'm now proud to officially announce that we're releasing that today after a series of alpha and beta releases. So this is the official release of Doppio 1. So it is downloadable from the CCP-EM downloads page on our website. There's the URL down there. In case you, that's my pointer, but down the bottom right. Because it's wrapping quite a number of other packages, the installation process at the moment is, well, the installation of Doppio is very straightforward, but you have to make sure that you install all of the underlying programs as well. There are instructions in the Doppio user guide, so the advice is to follow the instructions carefully to make sure you're picking up the right version of Relion, the right version of Ender and Tempe and things like this. We have a desk here at this conference. It's not very well marked up because we're poor academics. But if you go along the main corridor there, you should find a desk with CCP-EM staff who are more than happy to give you demos of Doppio and to talk to you about installation. We've also set up, so I referred to earlier, our training courses where we use cloud instances running back home. We've got a few of these cloud instances set up. So if you talk to the CCP-EM guys, we can set you up so that you can run it on our cloud service and get used to the feel of Doppio. So finally, the last 5 minutes, a few things for the future. So we're covering mainly single particle and helical reconstruction at the moment, but we're moving into tomography, largely, and subtomogram averaging, largely based around the Relion suite of tools. So we're working on pipeliner tasks and Doppio interfaces for tomography. This is in development. It's not available yet, but it covers all of the standard processes of going through tilt series alignment, reconstruction, 3D particle picking, subtomogram averaging. The pipeliner version is available here if you want to go and have a look at it and do set up your own tomographic workflows. Just say we're largely doing this, or we're being driven by a collaboration with Zach Freiberg at University of Pittsburgh, who has a nice set of in situ tilt series that we're using for practice. So some fairly challenging examples to try and do a good reconstruction and find sufficient particles. So that this is closely related to Relion 5 Beta 3 that Shaw's announced a couple of days ago. So that's to kind of repeat his email, bioarchive on that is just out, and there's a tutorial for doing tomographic subtomogram averaging in Relion, and the Doppio interface will follow that pretty closely. Yes, I mentioned themes briefly before. There will be a tomography theme in Doppio. All the themes have different colors. So if you see some garish magenta purple thing, that means you're doing tomography. So this is the draft Doppio interface. So set up in a similar way to the other interfaces, but allowing you to go step by step through tomography. And that's just a schematic of a kind of workflow that you can do within Doppio. We set up the CCP-EM website many years ago, based on my personal tastes and preferences. As I've been slowly shoved off to one side, they've tried to modernize the website, and we will have a new website coming out soon, which is much more modern and clean and slick and has all of those flashy things which annoy me. Finally, look to highlight a couple of posters that are in the session here. So poster 48 is on RUDMAS, which is a toolkit for looking at heterogeneous reconstruction. Go and have a look at that poster. And then poster 55 from Yola is looking at image classification using an affinity autoencoder. So again, go and have a look at the poster for that. Just a reminder to come to the CCP-EM desk if you want to find out anything more about Doppio. And finally, that's it. Last slide is the acknowledgements. So I should thank various funding sources, core funding from MRC, but we're also getting funding from government office technology transfer and from the STFC Ada Lovelace Centre and from our commercial license holders. And we have a wide network of here, the core staff in the middle, collaborators around the outside, and it's a much wider network than that, but those are the ones that we could hit on. And thank you for your attention.